Hello viewers, in today's video we want to look at azimuthal quantum number. Remember, in our previous video we have already looked at what quantum number is, what principal quantum number is, and in our subsequent video we are going to look at the magnetic quantum number and the spin quantum number. So when we talk about azimuthal quantum number, we are looking at the shape of an orbital. Azimuthal quantum number tells us the shape of an orbital and the subshell in which an electron is. There are two things that azimuthal quantum number tells us. One, the shape of an orbital. Two, the subshell in which an electron is. Now, azimuthal quantum number is denoted by a letter. Look at the letter here. Do you get that? And has a value of n minus 1, because principal quantum number is denoted by what? A letter n, and principal quantum number has what? N is equals to 1. So if principal quantum number is 1, azimuthal quantum number is what? N minus 1, in such a way that if principal quantum number is equals to 1, azimuthal quantum number will be equals to what? 0, because 1 minus 1 will give us what? It gives us 0. Do you get that? So if the principal quantum number is n is equals to 3, the value of azimuthal quantum number will be equals to what? Will be equals to 0, 1, and what? 3. There are three values. 1 and what? And 2. Do you get that? 1, 2, 3 will give you the principal quantum number. Azimuthal quantum number will be what? 0, 1, 2. Do you get that? So we are going to look at the table to describe both the shape, both the subshell, and everything about azimuthal quantum number. So we are going to look at the first thing we are going to look at is the value, the n, the value of what? We see the L value. The L value. And I've told you that the L value ranges from what? From 0, 1, 2, 3, 4. Do you get that? Now, we get that azimuthal quantum number 3 has to do with the subshell. And the subshell of azimuthal quantum number is what? SPDF. SPDF. S here stands for sharp. P here stands for principal. Principal is the meaning of what? SPDF. These are the subshell of an atom. So we now have subshell. Subshell, we have what? The first subshell is what? X. The second subshell is what? Principal, P. But before you now write the electronic configuration of this F finish, we'll get to that 118 element. Okay, so we have all this one. Now, what is the shape? What is the shape of S? S is spherical. S is what? Spherical in shape. P here is dumbbell. P here is dumbbell. P complex. Now we are going to look at the S here. How many orbitals? The number of orbitals that S have. Number of orbital. The number of orbitals is represented by the formula 2L plus 1. 2L plus 1. It means that these two now, for the first orbital here, write 2. The L, the azimuthal quantum number what is 0. So bracket, L times what? 0 plus what? 1 is equals to what? 2 times 0 will give us what? 0 plus 1 will give us what? 1. So the number of orbital here is what? 1. So the s orbital has what? 1. Now go to the second one. The value of L is what? 1. So say 2 times 1 plus 1. 2 times 1 give us what? 2 plus 1 give us what? Equals to what? 3. So the here is what? The orbital here is what? 7. So this is the, now how many electrons can occupy each of these orbital? How many electrons, number of that can occupy, say maximum, let me write maximum number of electron. Maximum number of electron in each of this shell is what? You use this formula, the same thing, say 2 bracket 2L plus 1. So whatever you have here, you multiply by 2. That is what it means. Whatever you have here, you multiply by what? By 2. This is the formula of what? Calculating the number of orbital. So you now multiply the 2 by that formula. So you now have what? At the end here, we have, you multiply this one by 2, give us what? 2. Multiply this one by 2, give us what? Give us 6. Multiply this one by 2, give us what? 10. Multiply this one by 2, give us what? 14. So the number of electrons that can occupy the f orbital is what? Is 4. Principal quantum number, if n is equals to 3, how many electrons can occupy this shell? Or what is the number of what? Orbital. Remember, if n is equals to 3, L will be equals to what? 0, 1, and 1, and 2. Do you get that? It means that this 3 that is here, this 3 has 3. 0 is what? Look at 0 is what? S. You have 3S. 1 is what? 1 is P. You have 3P. 2 is what? D. So 3D. Do you understand? Now, how many electrons can be found in here? How many electrons can this one occupy if N is equals to 3? How many electrons can occupy this one? Remember, S here carry what? A maximum of what? A maximum of 2 electrons. 2 equals to 2. Here is what? Occupy a maximum number of what? 10. So you add 2 plus 6 will give us what? Give us 8 plus 6 will give us what? Give us 18. So there are 18 electrons in if the principal quantum number is equals to what? 2.